So yeah, hello everyone. Hope you and all your families are all healthy and happy. Today I'm really excited to give you an insight as to how you can begin your journey to be a machine learning engineer. So the insight that I'm going to give you is from my personal experience and the industry's perspective as to what is the demand in the freshers who are coming in as an aspirant to be a machine learning engineer. So without any delays, let's proceed. So what we're going to understand today is like how do we understand this buzzword machine learning, understand why do we actually need machine learning. There are a lot of definitions that are given online, but today I would like to give you a realistic perspective as to what is it, why we need it, and how and what are the missing elements that we have been skipping out all this long. Then the most important and the most vital aspect that I feel is that there has been a lot of delusion between machine learning and data science. So I'll definitely ensure to clear that out as well. Then we'll be understanding the key aspects that we should take care and use as we proceed to the journey, along the journey. And the rest would be a little mystery, and you'll know it as you move along. Okay, so let's understand this buzzword machine learning. So basically machine learning is like, you would see that we convert data which would be in any format, which is strings, which is images. We convert that into number and we try to find out patterns within it. Okay, so well, the way, okay, and there has, so machine learning is defined as software 2.0, and but there has been an important aspect that we have been missing all this long, which is software 1.0, which is the software engineering part, one of the most key aspects. Okay, so let's move forward and I'll ensure that we collaborate both software 1.0 and software 2.0 together, and we go ahead and prove our skill set. Okay, so now the most important question, that why do we actually need machine learning? So like everyone would say like, why not? It's such a life savior. It's providing such a good business prospect. A lot of business have been building around it. But the most logical answer that I feel is that we cannot think of all the rules and scenarios when we are solving any business problem. Like machine learning is solving the issue wherein we would type like thousands, 10,000 lines of code using just if and else statements. Okay. But there's one aspect that you all need to take care of. That is, if you can build a simple rule-based system that doesn't require machine learning, then please do it. This is what the experts at Google say in their Google's machine learning handbook. Okay, so as I said, that there has been a lot of illusion of machine learning, data science being the same things. So I would like to really clear this out before we proceed any further. So you could consider that a data scientist would typically use those pre-built machine learning models to solve the business problems, whereas in case of machine learning engineer, he would go deeper into writing machine learning models from the scratch and the math behind the problem, right? So we could say that machine learning engineers feed those data into models defined by the data scientists, and they're also responsible for taking the theoretical data science models and helping them scale out into production level so that they can handle terabytes, because when we talk about machine learning, we deal in terabytes of real-time data. Okay, so just giving an example, so if you were a machine learning engineer creating a product to give recommendations to the users, what your role would be to be actually writing that live code that would eventually be used by a user at the end, and the data scientist would be probably bit of a part, maybe helping you determine what features should you use to you should use to get a better result. So it's more about like a data scientist could be considered as a person who's more of an amalgamation of tech and business knowledge, whereas the machine learning is what a core tech person. So I'll show you like what are the JDs of Google in terms of data scientists and machine learning. Okay, so just a second. Okay, so now what you're seeing is a data scientist profile by Google, requirement that is stated by Google. So what you can see over here is that they require degrees in statistics, mathematics, computational economics, and all. And moreover, they require your experience with the statistical software and database languages. And the most important point that you need to understand is this one: experience articulating and translating business questions and using statistical techniques to arrive at an answer using the available data. Okay, so, and now I'll share with you, just a second. Now I'll share with you what a machine learning engineer's profile looks like. Right. So this is soft machine learning engineers requirements. So now you see the major difference that comes now is an engineering degree that they mostly require. Okay, then you come here and you see that they need experience designing and implementing software systems using Python or some language. Okay, and then this is an most important part wherein you require work experience in machine learning software development. This is what is traditional programming, or what you can call it as software 1.0. Okay, so I hope that this delusion is something that I could clear out for you all today. So can I get a yes or a no in the chat window maybe?
Yes, yes.
Okay, great. So let's move forward now. Now we'll discuss about the key mantras that you need to take in it. The most important is patience. You really need to be patient in terms of your progress, in terms of gathering knowledge and achieving your goals, because nothing happens overnight. Second, the most important is consistency. So that means no 0 days. You start it and you have to keep going, because computer science or any field, I would say, you are never at your 100% in terms of knowledge that we have. You have to keep learning, you have to keep going every day and keep learning the new things. And our stream is something wherein every day a new framework, every day a new language, something better than the existing one comes. So we need to be updated and we need to keep going. Third is you cannot learn it all. So the best way that we as computer science engineers use in our initial days, and as always, divide and conquer. Divide it into small bits and then learn each of them, then move forward, come to an advanced stage, divide it again, conquer each one of them. That's the best way you can probably move ahead. And you as a person know how you tend to learn things, so you have to create your way of learning machine learning as to how will you do it, because you know your brain better and you know how it learns, reads, be it watching by only you. Like, I personally don't read books a lot. I prefer to learn using YouTube videos. So let's begin then. So first thing, we need to pick a language. Language is the way we'll communicate with our machines as to what needs to be done and how it needs to be done. Okay, so my recommendation in this case would be Python. You could definitely go for Java, C++, whichever is comfortable for you. But the reason why I recommend Java is that, first thing, it's versatile. It has a great library ecosystem, be it for gaming, be it for developing great UIs, be it for creating great webhooks, for web development, for machine learning, for everything. It has some of the other libraries that exists. Second important thing, it's very simple. So it has a very low entry barrier. Python, has been something that resembles our English language a lot. So, the learning process is very easy. So if you're starting and you start with Java, maybe you might take a month or more to learn Java. But Python, probably you could start with the basics and get a hold of those basics probably in a month, depending on the speed at which you learn. Third thing, it's very flexible. You want to go for scripting, you want to implement OOPS concepts, everything can be done in it. And there is no need to recompile your source code. Developers can implement any changes and quickly see the results within no time. And programmers can combine Python with others language. That's the best thing I really love about Python, which is its integration with Java or C, which are named as Jython and Python. So, you could leverage the ease of Python, whereas use those optimized techniques that exist in Python, C or Java. Then comes the part where Python has seen its growth, which is the massive online support. There are a lot of communities, there are a lot of documentations, forums, where programmers and machine learning developers discuss errors, problems, and help each other out. So if you have any problems, just go out. There are lots of forums on Telegrams, Slack, Discord. Just go there, post a problem, and I guarantee you within an hour or so you'll get you'll get a reply for it. Now the question comes, how do we learn it? Because today is an era of the 21st century. We have a plethora of resources available online. So it gets quite confusing as to how do we do it. So the most important thing is you need to research. Though I will leave some good resources that have really worked well for me at the end of this webinar. So keep researching and see which instructor suits your brain the best, because when we learn, we mostly remember the teachers that taught us in the school as well. We always remember the teachers who taught us, who made us excited about that concept. So, keep researching. One more thing that I've seen has become very common and has been trending like anything is people have been going a lot behind the certificates. But understand that certifications are nice, but you're not after them. What you're after is the skills. So don't make the mistakes to think that more certificates equals more skills. Really, that's not. And how much in the initials do you need to learn is understand the Python basics, what all data structures Python encompasses within itself. Use ML tools from the start. Like we usually tend to go for Visual Studio Code or PyCharm. I would recommend start with Jupyter notebooks so that you're really getting yourself acquainted with the main ML tool. Learn Git and GitHub and use GitHub to execute those Git commands. And you learn what versioning means, what version control systems do, and how really, because trust me, they're a boon for you when you enter the industries. You will not be the only person who will be actually, implementing those code, and you'll be making probably modules of that code or some significant part of it, but not the entire. And learn Flask, which is a framework for web development. Trust me, Flask is just like you can start a server within 2 or 3 lines of code. Trust me, that simple it is. Now let's dive into machine learning. So what should be the starting stage? First thing, since you have now learned the basics of Python, you now understand how Jupyter notebooks work. Let's understand pandas, NumPy, and matplotlib. So pandas is what will help you work with those data frames, those tables, those Excel files that will have probably tens, 20,000s of rows of data. So you'll need to work on them. So pandas is going to be your savior over there. NumPy is something that will help you perform those numerical operations on your data. Okay, because it's machine learning. That means whatever we send goes to the machine, and machine does not understand English or any kind of string. It understands only numerics. So that's what we will be needing. Then matplotlib is something that will help you visualize your results that you would train. Whatever results you get, you'll be able to actually visualize them, because the best way to communicate your results to someone or yourself is visual aspects. Then what I would say is, how would you gather data? So there are a plethora of resources that are available. You can go to Google dataset search engine, just search for something. For example, if you're going and making a COVID-19 visualization dashboard, something, this is the best place for any kind of data sets. You have government data sets, you have Kaggle data sets, you have Amazon data sets, which are free and open for everyone. Or probably if you have a custom project whose data is not probably existing in any of these data set platforms, you could use web scraping. You could, or probably hit the APIs of websites that have their open source APIs. Okay, Then we come to the part where you now need to process your data to meet your business objective or probably your personal project objective. So you start with handling the null values if there are any. You go for standardization. So what standardization means is that you convert the structure of different data sets into one common format of data, because you cannot have varying formats of data. Okay, then you go for handling categorical data. You go for one hot encoding, which is again what is converting strings into numerics. Then you go for feature scaling. Now there is one thing that most of the people have asked me is that when we research for a model, it is very difficult to decide which one to choose. So it's mostly what you would eventually do is you would go online, you would search, okay, which one is the best, this versus this. But probably that's not the most effective way, because one algorithm could be good for you in a certain use case, whereas the other could be better in other use case. So, it depends on the use case or probably your business objective. So the best way to, understand what kind of model would suit your objective the best is using implementing it for a long time, is cross validation. So what you do is, so just take an example, you have probably 30 rows of data. You usually don't have 30 rows, it's just an example. So what you would do is eventually you would split them into three equal parts, which is 10, 10, 10. So now what you would do is you would train your model on the first two, then you would test it on the third one that you had left out, you did not put it on train. Again, then you would change it to first and third for training, and the second, which was left out, for testing. And the same way, using second and third for training and the first one for testing. So this, the way when you do this, after this, the performance measures that you got from them, that how have they performed, what has been the prediction percentage, you can average them, and then that's what will estimate the capability of the algorithm on your problem. Next that you should go ahead with is machine learning, scikit-learn and TensorFlow. So scikit-learn is like, okay, so machine learning, you have heard about different kinds of types, which is classify, which is supervised, unsupervised, reinforcement. So within classified, and there are different kinds of algorithms. So within supervised, you could say there's classification, and under classification there is regression. So you are not going to sit and actually code the entire math of regression. So for that you have such kind of libraries which already have those algorithms implemented. So you can just call them and you can start using it for your purpose. Just feed in the data to that algorithm and you're good to go. So scikit-learn would help in that. And TensorFlow will help you build and deploy your applications when you are at a stage when you intend to scale your application, when you're dealing with different levels of data and probably gigabytes, terabytes, because that's the point where your machine would not actually be suitable to perform those tasks. Then as you implement your solution, just see what has been the prediction. Maybe your first iteration of building your machine learning model is providing a prediction or probably an accuracy of maybe 60-70%, but what your objective is that I wish to take it to 95%, 98%. So tune your model, look for what is actually causing those problems through feedback and research. Most important thing is research, because building things becomes research. You'll want your models to work faster and better, and to achieve this you'll need to research alternative ways of doing it. So you'll find yourself reading research papers, replicating them, and probably improving on them. So that's the best way you can actually go ahead. And then use matplotlibs to actually visualize your results, and maybe you can even store it to later. As this were the I actually made, and this is how I was able to get results. And the best point that I would like to highlight over here is when you're doing these kinds of analysis and you're able to tune your model, you're able to get better results, just keep a note of them with you, because that's what will help you in the future also, when you would be probably stuck at a massive, when you're dealing with massive amount of data, and that's where probably these kinds of learning would be a savior for you. And the best way I would say is to use Google Colab, because in the initial, when you're using your own systems, using the Jupyter notebook, at at a point you'll reach a saturation where your machine would not be able to, you know, like it would have maxed out its performance capabilities. So use Google Colab. It is a GPU powered Jupyter notebook, so you won't have any issues when you're dealing with a massive amount of data, anything. So I think Google Colab is a good tool that you could use. Now, the most important and the most beautiful horror, the maths. So there are, like I have highlighted these 6 concepts that primarily form the basic part of, not the basic, most important part of maths. There are others as well, but these are the ones that you can probably start with. So basically, linear algebra will be used in data pre-processing, data transformation, and your model evaluation. And matrix multiplication could be considered as a part of it. Then calculus, it would play an integral role. Definitely, it has been a horror for most of us during our 11th and 12th standards. But trust me, it plays an integral role in understanding the internal workings of machine learning algorithms, such as gradient descent that minimizes the error function based on computation of the rate of change. Then statistics. Statistics will help you analyze and visualize data to find unseen patterns. Definitely, your ultimate objective is to find patterns in your data. That's the reason ML comes into picture. Then probability and distribution would form the basis of your sampling. Sometimes for testing purposes, you would actually take a sample out of your really, terabytes of data or gigabytes of data to actually train and test your. So how do you do that? You're going to do it through probability. Okay, because in machine learning, uncertainty may arise in any way. For example, like you have noise in your data. So probability provides a set of tools to model your uncertainty. Okay. Now, one of the most important, like, or what you would say is that how much maths should I know before I actually start machine learning? So I would say begin with the basics of these, but when you're stuck at a problem, what most importantly matters is, can you solve that problem that you're working on? If yes, trust me, you know enough. If not, go ahead, learn more as and when you need it. So I would say that don't stick that, okay, because maths is something that is like an ocean. You would get tired learning it, but there's no end to it. So learn as you need. That's the best way to progress and get things started really soon. Okay. Then now what we need to do is that whatever app you're making, it mostly, comes and dies. It takes birth in a Jupyter notebook cell and it ends there. That's the only life cycle that probably most of the machine learning projects have been. And that's how they just go to your GitHub profiles. But what's really important, and what this is one of the most required skill sets by industry, like where I am working right now and the clients that I have been working on, this has been one of those primary skill sets they have been really wanting, but they've probably only gotten those 5 or 10% of the entire talent pool that is applying to their firm. So these 3 can be those crucial aspects and crucial skill sets that you can add to your profile and stay ahead of your competitors. So let me just explain a little bit as to what these 3 skill sets are. So CI/CD is like a modern software development practice. So what happens is, like, you design those automated build and test steps which are triggered by those CI, which is continuous integration, and that ensure that the code changes being merged into repositories are reliable. So for example, I'm making a calculator today, and now me and one of my friend is working on building different functions of the calculator. For example, I'm making the addition and my friend is making a subtraction, but there has been an underlying foundation that has already been laid inside that. So in that, you need to ensure that whatever code I am pushing, it is reliable. It does not have anything that would break the existing foundation that has been laid. So for that, we ensure and we run some automated tests on every commit or every code save that we do in our repository. Okay, and every change that passes those automated tests is automatically placed in your production as part of continuous delivery. That is what stands for CD. Now coming to Docker. So Docker is a tool that is designed to make it easier to create, deploy, and run application using containers. So what happens is, My calculator needs Python. It needs some of like 2 more libraries as a part of its dependencies to run. So what I'll do is I'll pack them within a container, and then I'll publish it to the cloud so that anyone who runs it will not have to download Python in his system, download those dependencies, and only then will he build. He just needs to have Docker in his computer or a system, and then he's ready to go and run it. Then what Kubernetes is for is what will manage those containers. So for example, now my calculator is being used by only 2 people. Okay, but what if now I'm catering hundreds or thousands of people? How will I actually manage the memory and all other functions? So that is done by Kubernetes. Now, since you need to have your application accessible across anyone, like I should be able to access that calculator through my phone wherever I'm in the world. So for that, you need to pick a cloud technology provider. My recommendation would be to pick AWS. That is because the services that it provides is massive. Plus, most of the companies that have their inbuilt cloud networks, they're built on AWS. I'm not saying that Azure or GCP is bad, but the use of AWS is more than anyone. Okay, so now if you ever need any help, trust me, Google and Stack Overflow are your best friends. They will give you the best help that you can get. And if just in case you're not able to find a proper answer to a solution, you have your communities, you can join any of it, you'll get an answer, that's for sure. Okay, so this is one of those plans that you could probably follow. You can take a screenshot of it, and this is how you could begin your journey in the first 3 months of learning machine learning, wherein you could master the concepts that revolve on machine learning. You could master Python and the libraries that we use for data processing, and then build a project around it. Okay, once that project is built, you could probably advance to the more advanced concepts like deep learning, more getting those extra heavy algorithms for those extra extensive tasks, and then build another project around it. Build projects, build one, but build it in such a way and with such enthusiasm that it's published and people can actually start using it, because that's the best way you can actually showcase your talent to the companies. Because when it comes to machine learning and data science, these two fields require a lot of experience. So mostly companies prefer to take a person who is having a master's degree in AI or machine learning, rather than a person who's just coming out of his undergraduation. So the best way is during those first 4 years of your undergraduate degree, just keep working on this, and probably you might end up having at least 1 or 2 years of personal experience that you have built, but it might stand equivalent to some of those industrial experiences. Now, just a suggestion as to how you can actually build your project is through this. You can take a screenshot of this as well. So how you could actually plan research and plan in your first week. You could start your programming and prototyping in your week 2. Then you could actually iterate and start building your prototype in week 3, and you could start testing and shipping it in week 4. Probably like 4 weeks of hackathon that you could probably have for yourself. Now, one of the most important that I have felt has increased my knowledge a lot is through this inhale and exhale formula. Whatever projects you have, just share it, get feedbacks for it. Whatever learnings that you had seen in your journey of learning machine learning, share it with people through blogs, through videos, through social media handles like Twitter, maybe you posting a video about you on YouTube, on Medium. So this way, you would actually balance the consumption of your materials with creation of your own. So what I could say is, like, if you're spending like 6 weeks of learning, then 6 weeks putting your knowledge together in form of shared work. And this shared work is kind of the new age resumes that you have. Okay, site and some experience. So now what I feel is that you could probably, if you have any questions, you could just let me know. and you could just scan this QR code, and you could just post in those questions for me. Like since we're short of the time, I'll just send out those questions in terms of maybe a LinkedIn post. You can follow me on LinkedIn and Twitter as well. And if you get some time at the end of the second session, maybe I can just address these questions then. So you could just scan this QR. And like as I said, I would be providing some useful resources for all of you. So that would be in here. You can just scan this QR code and you'll have the links to a lot of vital resources that I have been following. I have used them, and I'll keep on adding to this link more. So if you just save this link with you somewhere, bookmark it, and you'll have all the resources. And I've tried to organize them in the way in which you would actually be learning those concepts. So yeah, thank you so much, everyone. It was really nice talking.
Thank you, Aditya, mate. So it was a nice session on the roadmap to machine learning. So I have one question. So how do you suggest for the profession to start with the machine learning? So basically, you have to tell more about the student point of view, right? But actually in the real scenario in the IT industry, how the machine learning is working, is how the professional engage on this part, how they can enhance their skill. So can you give a little insight on this part?
Okay, so basically, my entire talk has been revolving around the industry's perspective, but as I said, like when I said that there is a segregation between machine learning and data science, so you need to understand that in certain companies, these names are used interchangeably. Okay, and all those resources that I have provided in this link, they are very much apt to what the industry is wanting. Okay, so if you just go on this link, you'll find everything over there. So I've collected all those resources that I have used, what industries require. This, like, they're all are very much pinpointed to what industry wants from a machine learning engineer.
Okay, thank you. So Mukesh Tiwari ji has raised the hand, so you can ask the question in the chat box, or you can unmute your mic.
So thank you for the wonderful presentation. I would like a little bit of suggestion about how to start converting the code that we have implemented in Python notebooks to web applications. Like, I would specifically like your opinion about, do you suggest having our apps hosted on our own site, or have our work just shared as code with possibly a blog? So how do we start with this process? Like, we have created the code ourselves, but what do we do then?
Okay, so basically that's what I said, like in my slides, that most of our code ends up only being in Jupyter notebooks, and that's what we share. But trust me, that's not what anyone would like to see, because they don't want to go there and keep running those cells in your Jupyter notebooks. So the best way is that when you're using Python, learn those web frameworks, and for UI part, use a service called as Streamlit. Okay, I have given the link to it in my resources. You can use Streamlit for converting your projects into a application ready project. Okay, so use Streamlit. It's a really good resource, and through that you will save a lot of time on actually learning those UI based things, and all. You would be able to create it within a few days on Streamlit. I hope that answers. If I missed out anyone, you can just tell me. I'll ensure to answer that.
Thanks a lot. I was like, thank you so much for the answer, but I was also looking for, like, what about hosting the site? Like, do we pay for a service to host our site, or do we have some?
Yeah, you can use Heroku. So like it's a free service. Okay, you can use Heroku, or probably like for AWS as well, it provides you a certain amount of free bandwidth. So you could use AWS or Heroku to host your application.
Thank you.
You're welcome.
Okay, thank you very much, Mukeshji. So we will be wrapping with our next speaker. So thank you very much, Aditya. So it was one of the nice talk, on the roadmap, and I hope attendee has also got some insightful knowledge. So